So they ask you to prove this. We're just going to start with our left hand side. Okay, so our left hand side. If you look at this clearly, cos plus I sine that just cease, right? So just cease 2 theta minus 1. Okay, cease 2 theta minus 1. And then you need to observe the right hand side first. Okay, so right hand side that's cos theta minus I sine theta. Okay, if we have cos theta plus I sine theta, that will just be our cis theta, right? However, you can see this is a real minus imaginary. If we call this one z, that would just be the z conjugate, right? That would just be z conjugate. And so we're just going to start from, so this is a cis 2 theta. Okay, we're just going to let z equals to cis theta. Okay, z equals to cis theta because your right hand side is in terms of cis theta. So cis 2 theta equals to cis theta squared, which is your z squared, right? So the left hand side equals to 1 on z squared minus 1. 1 z squared minus 1. And you already realized on the top of the right hand side, this one here, cos minus I sine, that's that conjugate, right? So to create that conjugate, we need to multiply a z conjugate on both top and bottom. Right, therefore now the top is that conjugate which is cos theta minus I sine theta. Okay, that just equals to that conjugate is just cos theta minus I sine theta. And we also learned a very useful properties before, which is if you have r equals to 1, okay, when we have r equals to 1, z conjugate equals to z inverse. Right? They are exactly the same because they have the same magnitude. If r doesn't equals to 1, z conjugate equals to r cis minus theta. And z inverse equals to 1 on r cis minus theta. Right. However, you can see when they have the same magnitude, these two are just exactly the same. Z squared multiplied by Z conjugate, we don't know how to simplify it. However, we know Z conjugate equals to Z to the power of minus 1. So if you're using Z to the power of minus 1 multiplied by Z squared, that is equals to Z. Right? And then minus Z to the power of minus 1. Minus Z to the power of minus 1. So we have cos theta minus I sine theta, and then z is cos theta plus I sine theta minus z inverse, which is cis minus theta again, cos theta minus I sine theta, right? And we can see the cos and cos cancelled, cos and cos cancelled. I sine theta minus I sine theta, which is cos theta minus I sine theta divided by 2I sine theta. Okay, divided by 2I sine theta. This is our right hand side. Okay. So use the cis formulas and also using the conjugate and then the inverse formulas. And now let's have a look at the next part. So I told you W is the solution of z to the power of n equals 1, right? Yeah, so z to the power of n equals to 1. Okay. And then 1 equals to cis 0, which is cis 2 pi multiplied by n, right? Yeah, 2 pi multiplied by k. And then if we just want 1 roots, we can just let that k equals to 1, right? Because we just want 1 roots, k just equals to 1. So z to the power of n equals to cis 2 pi. Therefore, z equals to cis 2 pi divided by n. This is just your w, right? The first non-zero argument, okay? The nth root of unity. Okay? Yeah. So w equals to cis 2 pi over n, and then they ask you to find the real part of 1 over w minus 1. So for this question, all these type of questions, when they have a part B, they try to ask you to use whatever you proved before. Okay, you can see this, yeah, so this is 1 over something minus 1, right? 1 over something minus 1. You just need to let W equals to that, right? We just need to let W equals to this so we can use this formula. So we just let, okay, W equals to cos 2 theta plus I sine 2 theta. Remember, our W originally equals to 6, 2 multiplied by pi over n. Right? So this 2 fits perfectly. You just need to let theta equals to pi over n. Right? If theta equals pi over n, your W just equals to 6 to pi. Okay, yeah, so that's one of the substitution we need to make to use the first part. Okay, yeah. So this, yeah, so W equals to that equals to 6, 2 multiplied by pi over n, and then let theta equals to pi over n. Our W equals to 6 to theta. Okay, our W will just equals to 6 to theta. Remember, the substitution you used is this. And then 1 over W minus 1 would be 1 over 6 2 theta minus 1, which is cos theta minus I sine theta over 2I sine theta. Over 2I sine theta. So let's just separate them. Cos divided by sine, that's cot, right? So this is minus 1 on 2 I cot theta. And then I and I cancelled, sine and sine cancelled. Minus 1 divided by 2 is minus a half. Right? Yeah, so 1 over W minus 1 equals to minus a half I cot theta minus a half. So the red part is imaginary part, and then the black part is your real part, right? Imaginary part and the real part. Therefore, the real part of 1 over W minus 1 equals to minus a half.